সামস বা কোয়েশ্চেন গুলো প্র্যাকটিস করাবেন?
ওদিনকে হ্যাঁ কিছু সাউন্ডস প্র্যাকটিস করবো, কিছু কোয়েশ্চেন ডিসকাস করবো। ঠিক আছে, কিরকম কোয়েশ্চেন এলে কিরকম ভাবে হ্যান্ডেল করতে হবে কোয়েশ্চেন গুলো, সেইগুলোকে ডিসকাস করাবো। ঠিক আছে, ওকে। So we have done solid state physics, this lattice, physics, and Gravis lattice, and the crystal structure, 7 crystal systems. All those things we have done. Okay, and today a little bit only, and that is no need to go through the crystal planes and direction. We will be going through this interplanar spacing a little bit. You should know the formula on interplanar spacing. Means the atoms, we are just assuming that the atoms are lying in a plane. Now, if the atoms are lying in a plane, then there are several such planes in a crystal system. And if there are several such planes in a crystal system, then what will be the distance between the between these planes? So the distance between these planes actually depends on the HKL values and the ABC values. HKL values are simply Miller indices. You have read in chemistry, I know in class 11, 12, right? Isn't it? The HKL values and the ABC values. ABC are the primitive vectors, and it is given by d square into h square by a square plus k square by b square plus l square by c square, that is equals to 1. So this is the relation of the interplanar spacing with HKL and ABC. D is the interplanar spacing, means the distance, the shortest distance between two crystal planes. That is D. And if we are talking about a cube, then this can be written as D HKL equals to 1 by this thing, root over of this. Now, if we are talking about a cube or cubic structure, whether it is face-centered or body-centered or central cubic, doesn't matter, cubic structure. So for a cubic structure, we know A equals to B equals to C. And in that case, if you say A equals to B equals to C, that is equals to A you are writing, then the interplanar spacing just become A by root over of H square plus K square plus L square. This is the interplanar spacing for a cubic system. You can go through the interplanar spacing for a tetragonal system, interplanar spacing for an orthorhombic system. Orthorhombic system, obviously, since A is not equals to B is not equals to C, then obviously it will be simply this one. It will be simply this one. Provided your alpha, beta, gamma is equals to 90 degree. Alpha, beta, gamma is equals to 90 degree. If those are not 90 degree, then directly you cannot write this one. Okay. Next, we are coming to X-ray diffraction. Okay. Lau was the first to suggest in 1912 regarding the X-ray diffraction, that a crystalline solid may act on X-rays in a way which is similar to the grating on visible light. So this, what happens is this atomic crystal, the crystalline, if it is a crystalline solid, the atomic planes are just acts as mirrors to the X-ray which is falling on these crystal planes. Actually, those are diffracted. Why? Because the wavelength is comparable to the atomic dimension, and hence those are diffracted. But The thing is, this diffraction is actually we treat as the reflection. Okay, actually we have Bragg's law of diffraction, but we are treating that one as reflection. What is this Bragg's law? See, these are the things, these are the planes where the atoms are lying, these are the atoms. So, these two rays are coming, striking this atom and it is diffracted. Striking this atom, it is diffracted. But we are treating this one as reflection. So when this incident ray is coming and striking, at that point in time, this incident ray is over here. If you draw perpendicular, it has not come till B. So it is diffracted now. When it is diffracted already, so when it starts diffraction at that point of time, if you draw a perpendicular to this line, then it should be at C. That means if you talk about this incident ray, it is traveling a path AB and BC extra than this one. So this is the extra path travel. So what is the path difference between these two rays? The path difference is AB plus B. That is the path difference. And if D is the interatomic distance, D is the interatomic distance, then you can write this one as P equals to AB plus BC. That is nothing but D sine theta plus D sine theta. This AB, since this is D, this AB is nothing but this portion into sine theta, right? Since these are 90 degrees normal. So AB plus BC is nothing but D sine theta plus D sine theta. That is 2D sine theta. So the path difference is 2D sine theta. And if we think actually this is diffraction, but we are treating as reflection, Bragg's reflection from a set of planes repeated by a distance D it is rate. And if we think that the interfere, okay, that the interfere constructively, that means we are getting some light constructive interference, then obviously path difference should be an integral multiple of lambda. That we know, we have read already. আমি আবার interference একটু পড়াবো, but you know, for constructive interference, the path difference should be an integral multiple of lambda, the wavelength, right? So hence, path difference which we 2D sine theta, that should be equals to n lambda. So this is what we call Bragg's law. This equation is said to be Bragg's law. Is this clear? Understood? Any question? Any question you want to ask? কিছু প্রশ্ন আছে? Any question you want to ask? কিরে কোনো কোশ্চেন আছে?
না স্যার।
ওকে, এগুলো তো কিছুই বলছিস না, সব অন করে চলে গেছিস, জানিস স্যার ডাকবে, কিছু ডিসকাস করবে। আমি তো আওয়াজ শুনতেই পাচ্ছি না, জিজ্ঞেস করছি কোনো কোয়েশ্চেন আছে কিনা, কেউ কিছুই বলছিস। সে ভূমি হোক কিংবা তিথি হোক কিংবা সুমিত হোক কিংবা শুভান্তি কিংবা রোশন, কেউ কিছুই বলছিস না। যাই হোক, ওকে। সো দিস ইজ সিম্পলি দ্য ব্র্যাগস ল। এইটুকুই সলিড স্টেটে আছে। ওকে, আচ্ছা। নেক্সট
এটা শুধু স্যার ব্র্যাগস ল অবধি?
ব্র্যাগস ল তোমার, ঠিক আছে। সিএসবিএস আরো বেশি আছে F8 এর। F8 এর এখানে কেউ নেই, সুতরাং আমি আর ওইটুকু পড়াচ্ছি না। Okay. Next, we are coming to কি বলবো বলেছিলাম? Vectors. Okay, right. Vectors এর gradient divergence curl already আমরা করেছি. We have done the gradient divergence and curl. If you are asked what is the geometrical interpretation of the gradient, then what will be your answer?
Sir, normalization.
সেটা কি শুধু নরমালাইজেশন?
স্যার ওটাকে
Actually,
ন্যাবলা কি dr
gradient
cos theta?
dr cos theta. No, actually the gradient of a scalar field is a vector. We know that is a vector whose magnitude is equal to the maximum rate of change of scalar field and the direction is along that change. লিখে রাখবি? Want to write it?
Yes, sir.
Yes, sir.
The gradient of a scalar field. যারা ক্লাস করেনি তাদের একদম দিবি না, আজকে যারা ক্লাস করছেন। The gradient of a scalar field is the vector whose magnitude is equal to the maximum rate of change of scalar field to the maximum rate of change of the scalar field and the direction is along that change.